In this video, I'm going to check if the ordinary differential equation 1 plus y times exponent of xy plus 2yx plus x exponent of xy multiplied by the derivative of y with respect to x is equal to 0 is exact. When given a differential equation which is of the form m of xy dx plus n of xy dy equals to 0, the equation is exact if partial derivative of m with respect to y is equals to partial derivative of n with respect to x. Now looking at the equation that we are given there, I would like to write it first in this form. So to write it in that form, I will multiply it by the dx there. So when you multiply throughout by dx, we would have 1 plus y exponent of xy dx plus 2yx plus x exponent of xy dy is equals to 0. So it is now of this form. Therefore, you can now compare. Look at the coefficient of dx there. We have m of xy dx. The coefficient of dx there in this equation is 1 plus y exponent of xy. So by comparison, we see that our m there is 1 plus y exponent of xy. Now go on and look at the coefficient of dy. Here is the n. And in the equation that we are given, the coefficient is 2yx plus x exponent of xy. So by comparison of the two highlighted parts, we see that our n there is equal to 2yx plus x exponent of xy. So we now have our m and our n. I will now go on and evaluate the partial derivative of m with respect to y. For the partial derivative of m with respect to y, so I'll write it down there. We are looking at the first part there, differentiating with respect to y. So the first part there, what you're having is a 1. It's a constant. A constant differentiated with respect to y, we just have a 0. But looking at this part now, y exponent of xy. This is a product. To differentiate a product of the variable y there, we would have to use the product rule. If you still recall, the derivative of uv is equals to u prime v plus u multiplied by v prime. So in this case, what we are multiplying there is the y and the exponent of xy. So I will choose my u to be the y. And differentiate the u to get the u prime. So the derivative of u with respect to y will get a 1. Then my v will be the one that we are multiplying the exponent of xy. So v is equals to exponent of xy. I differentiate that v with respect to y, treating x as if it's a constant because this is a partial derivative. So therefore the v prime there will be equals to x multiplied by exponent of xy. So in our formula here, we are saying the derivative of this product there is u prime v. And we are saying our u prime is this one, the 1. Our v is exponent of xy. So the u prime v will be equals to exponent of xy. Then we go on to the uv prime. Our u is this one here. Our v prime is this one here. So if the uv prime will give us plus y x exponent of xy. I now move on to evaluating the partial derivative of n with respect to x. For the partial derivative of n with respect to x, I'll look at this part first here, 2yx. Differentiated with respect to x, treating y as if it's a constant, then we'll get 2y. Now go on to the second part of the n there, x exponent of xy. This is a product of functions of x. We're having the x multiplied by exponent of xy. So we'd have to use the product rule. The derivative of uv is equals to u prime v plus uv prime. So in this case, I'll take my u to be the x, differentiate the u with respect to x to get u prime. So we'd have u prime is equals to 1. My v will be the other part of that product there. So the v will be exponent of xy. Differentiate that with respect to x, treating y as if it's a constant. Then we would have y exponent of xy. Now for the product, we are saying it's equals to u prime v. Our u prime is this one, the 1. Our v is this one. So we would have u prime times v, it will give us exponent of xy. So I write the exponent of xy there. And then it's plus u v prime. Our u is the x, our v prime is y exponent of xy. So when we evaluate our u, v prime there, it will give us xy exponent of xy. So that's the partial derivative of n with respect to x. Now for this differential equation to be exact, we said these two partial derivatives must be equal. But what we are having there is the partial derivative of m with respect to y is this one, exponent of xy plus y x exponent of xy. The partial derivative of n with respect to x is 2y exponent of xy plus xy exponent of xy. What we are seeing there is those two highlighted parts, they are not equal. So this condition here for a differential equation to be exact is not being satisfied. So that differential equation there is not exact, since we are having the partial derivative of m with respect to y is not equal to the partial derivative of n with respect to x.